Hey folks, Joe Montana here, and this calculus lesson is more on the shell method. Except we're adjusting to shifts. So say we're adjusting, we're going to reflect it around, say, the line y equals 2. Well, y equals 2 is a horizontal line, so that would be parallel to the x-axis. So you treat it like an x-axis thing, and x equals some number is a vertical line. So that's parallel to the y-axis, so you treat that like a y-axis with the shells. Remember, shell method is opposites, so if we have a y-axis or a y-parallel axis, like x equal 1, then we want the equations in terms of opposites, so we'd want it in terms of x equals y equations if it was going vertical. Okay, so let's try this. So expand the formulas here. Uh, all right, so volume equals, on shells, 2 pi x times f of x, and then this x part is the right minus left, and f of x is top minus bottom. And this is when it's you're revolving around the y-axis or something parallel to the y-axis, okay? So this is y equals x equations around the y-axis or something parallel to the y-axis. And then it's 2 pi r, and this is y, and this is g of y, so this would be x equals y equations when it's about the x-axis or something parallel to the x-axis. All right, so and then this a thing, you guys, is just your axis. So like it would, on this case, it would be a would be like x equals 1 or something like that. Okay, I have examples on all of this here. So typically, I would use a disk washer when everything's the same. So if it was around the y-axis and I had x equals y equations, I'd use disk and washers. If it was around the x-axis and I had y equals x equations, I'd use disk and washers. Shells is opposites, but section 6.3 is all about shells, so we're going to do opposites on this, you guys. So revolve the region bounded by the region bounded by, and we're find the volumes of these. So y equals x squared, y equals x plus 2, and x equals 3. All right, so here we go. Here's y equals x squared in blue. Here's the line y equals x plus 2, and then we're going to revolve it around this line, okay? Now this line is parallel to the y-axis, okay? So I have y equals x equations around something parallel to the y-axis. So this is going to be a definite shell one. So volume is 2 pi times, and then this is righty minus lefty. Okay, so my righty is this one right here minus the left, which is an x right here. So righty minus lefty, and then top minus bottom would be the line. Looks like the top is the line minus the bottom, the parabola. Okay, so here's right minus left, here's top minus bottom. Okay, and so this is just my shifting right here. So righty minus lefty is 3 minus x. Okay, all right, and then you're going to go ahead and plug that in your calculator, and you get 45 pi over 2. Okay, so shell method is 2 pi, and it's x times f of x, okay? But this time the x is the righty minus lefty is the shift, so I'm adjusting to the shift, okay? So righty minus lefty, all right? All right, let's try it, same thing, but at about x equals negative 2, okay? So that's just going to be over there, and it's still going to be the same thing, except my righty minus lefty, you guys, is going to be, sorry, I made a big old mess right there. So my righty minus lefty right here, this is my righty right here. So think of this x equals some line right here, and my lefty would be this equation. So it's going to be x minus a minus 2 for the radius of that. And then top minus bottom would again be the line minus the parabola right there. Okay, so sorry, it gets kind of messy when you're doing this, and I'm trying to show you the shell method right there. Okay, so here's my x equals. This is my x equals, and it's going to be the radius right here is right minus left. So my right is this x minus the left right here, negative 2. Okay, and then go ahead and clean that up and simplify, and you get that as your answer. Okay, now this one here, notice I have about y equals 4. Y equals 4 is a horizontal line, which is parallel to the x-axis. Typically I'd do a disk washer method on this, but this is section 6.3, and they're asking us to find the volume using the shell method. So what I'm going to have to do is I want these to be I want these to be x equals y equations, because this is like y equals 4 is parallel to the x-axis, so I want them to be opposites. So I'm going to have to solve this for x and solve this for x right here. Okay, let's go ahead and graph that, though. It's the same equations as before right there. So there's x cubed plus 1, x equals 1, and then this red line right here. All right, and then we're going to go about y equals 4. Okay, so it's flipping like that. Okay, so top minus bottom right here is this guy right here, top minus bottom. So the top is going to be this y equals 4, and then the bottom, we're going to have to get it in terms of x equals y equations. Now, I've zoomed in on this little part right here, x equals y equations, you guys, so it splits right there at y equals 1 right here. So top minus bottom would be, here's top minus the bottom right here, so it splits between y equal half to y equal 1, and then from y equal 1 to y equal 2 right there. Alrighty, so top minus bottom is 4 minus y. Okay, here's my y right here. Y equals whatever that is right there. Okay, and then righty minus lefty right here. See, it splits from right here. It goes right minus left is this x equals 1 right here to x equals this linear equation right here. So when I solve this for x right here, I get 2 minus 2y right there. Okay, and then it splits again right here from this y to this y right here, so it splits at y equals 1 right here. So I'm going to have the integral from 1/2 to 1, and then again the integral from 1 to 2, because righty minus lefty goes from, here's righty minus lefty, and then here's righty again minus lefty. So it goes from this line to this line, and here it goes from this line to this cubic equation right there. Okay, so I get that right there. Okay, see here, I would have done the disc and washer method right here, because this is parallel to the x-axis right here, and you had them in terms of y equals x equations. I would have done the disc and washer method. Anyways, though, if I did it right, you would have got 9.23 on that. Watch, I'll show you the disc and washer method. If they didn't tell me to do it by the shell method, and I think they do in this lesson, but if I did it by the disc and washer method, remember it goes pi r squared, except it's going to be the outer circle minus the inner circle. Okay, so the outer circle is, the radius of the outer circle is top minus bottom, so it's 4 minus the linear equation right here, and then the inner circle is going to be 4 minus the cubic equation inside of there. Okay, so here the outer is going to go right here, and the inner is going to go right there. So if I plug that in, I find the disc and washer method to be a heck of a lot easier right there, and so you get the same answer. You should get the same answer. Anyways, if you're in my calculus class, that would be your homework assignment. Take care, you guys.